Hey guys, this is Mrs. Carney coming at you live. It is Sunday, April 5th, and I'm about to record a 7.3 notes walkthrough about solving systems of equations using addition or subtraction. And we're designing this learning specifically for our remote learning situation in the year 2020. And so I hope that this makes sense. But feel free to check in with your math teacher in the Zoom check-in hours if you have any questions, and keep track as you go if anything stands out at you as something that you're not sure about. So first, I just want to talk about what our goals are for today. So our goals are going to be to find the solution to a system using addition or subtraction, the goal being that we're going to eliminate a variable. And I think you'll find that it'll be kind of nice and smooth, hopefully. And so the first thing that I want you to try is, this says some random background info from a long, long time ago. And so on a piece of paper, I actually want you to do this. And even if it's on your notes, like if you printed your notes, you could even do it over here, or if it's on Notability, you could do this. But I want you to pause the video in a second when I say to, and I want you to add 743 and 18. So I'm going to give you a second to do that. So go ahead and pause the video, and whether you're on paper or somewhere else, Notability, go ahead and pause and add 743 and 18. Go for it. Okay, and I'm actually not even interested in the right answer, but what I'm curious about is, did you set your problem up like this? 743 plus 18. And so the things that I really want you to pay attention to are, look at that line that you probably drew. And if you didn't, it's totally fine. But a lot of people that would add these two numbers would do this. So look at that line and then look at this plus, right? And we're going to come back to this later. So I want you to remember how you set this up. And so then let's just scroll down a little bit. And so it says, so far we've learned to solve a system of equations using the graphing method. And so if you remember on Desmos, or before school kind of got out, we were focusing on graphing two lines and finding where they intersected. And so what I want you to do really quick, again, I want you to pause the video, and I want you to press play when you're ready to check your answer. I want you to take these 4 words, this is like our little word bank, and I want you to fill in this sentence frame in the way that would make the most sense. So pause the video, go ahead and do that, and then press play when you're ready to check your answer. Okay, and so when we solved by graphing, we were graphing 2 lines, and we were finding the point of intersection. So now we're going to learn a different way to solve a system of equations, and the way it's generally referred to is called elimination, or we're going to be eliminating a variable. And we're either going to add our equations together, or we're going to subtract them from each other, depending on which of those two things, addition or subtraction, can make a variable disappear or eliminate itself. And so the first example that we're going to do is going to involve addition. And so you'll see here there are some steps, and we're going to fill those in as we go. And then we're also going to do this example. Now this is kind of like the clean typed example, and then this is just a picture that we're going to refer to. So the first thing it says is to draw a line below your equation. So if you remember, that is very similar to when we added the 743 plus 18. And so when I say draw a line below your equations, I'm talking about that line that we drew. And so that's what this line represents. So we're going to draw a line below our equations. And then we're going to just kind of look and decide which operation, and our choices are either addition or subtraction, would cause a variable to eliminate itself. And so in this case, if I look at my y's, well, if I add those, 3 and 5 add to 8, and 3 and 5 subtract to get either 2 or negative 2, the one that I can cause to eliminate is x, and it would be by adding 2x and negative 2x. And so my method is to draw a little circle here, and then to actually put in the operation, either addition or subtraction, into that circle. And so in this case, it's addition, because 2x plus negative 2x equals 0. And so now we're going to add each term, x, y, or constant term, together to create a new equation, and one of your variables should be eliminated. Now I call this the tap, tap, tap method, and if I was in class teaching you, I'd actually be touching the whiteboard, and so I would say 2x plus negative 2x. Well, that's 0. It's gone. I don't even have to write it. And you can actually hear me tapping, right? So I'm touching these things. I'm talking to myself. I'm trying to make sure that I don't make any mistakes. And so then I would do 3y plus 5y. And what's 3y plus 5y? Well, we know that that's 8y. And just like I've always done, and not that everybody doesn't draw that line, but a lot of people do. And so I'm going to bring my equal sign right down at that line. And now I'm going to add again. And so I'm going to add 11 plus 13. This isn't too difficult when it's all positive numbers, but once we start adding in negatives and things like that, it's going to be helpful to do this like tap, tap, tap. And so now I look at my new equation. And so my new equation has a single variable. And so if I look at step 4, and by the way, one of my variables is eliminated. X is gone. And again, that was because 2x plus negative 2x is 0. It's gone. And so now I'm going to solve the equation that I have by isolating the remaining variable. And so I happen to have y as my remaining variable. It won't always be the case. Sometimes it'll be x. And since y is being bothered by 8 and it's being bothered by multiplication, I'm going to divide by 8 on both sides, which means that y equals 3. But remember, if we go back to the graphing method, a solution to a system is the point of intersection. And remember, points are made up of x's and y's. And so right now I only have half of my answer. And so now I need to actually plug this answer, y equals 3, into one of my two equations. It won't matter which one you pick. Some people might pick the top one because it comes first. I might pick the top one in this case because it doesn't have a negative. But so that means wherever I see a y, I'm going to replace it with 3. And so I'm going to do 2x plus 3 times 3 equals 11. And now I'm going to get x by itself. And I'm going to follow that simplify, distribute, combine, balance answer. So I've got 2x plus 3 times 3 is 9 equals 11. I'm going to subtract 9 from both sides because I'm going to undo addition before I undo multiplication, because remember, when we're solving, we go reverse PEMDAS. And then I'm going to divide both sides by 2, and so now I have x equals 1. And again, some people will just stop there. They get excited. They've accomplished something. You've done some really good work at this point. But remember, the solution is actually the point of intersection, and points look like this. And so I just want to make sure that I actually write my answer in XY format. And so in that case, it's 1, 3. And so what that means is, if I were to actually graph this system, if I had graphed it by making a table or using x and y intercepts or slope-intercept form, I would see 2 lines, and I would expect both of those lines to intersect at the point 1, 3. I can check my answer if I want to by actually replacing x with 1 and y with 3 in both equations. And so if I just kind of do that for a second, I would do 2 times 1 is 2, 3 times 3 is 9, 2 plus 9 is 11. Okay, check. Negative 2 times 1 is negative 2. 5 times 3 is 15, and negative 2 plus 15 is 13. Check, check. It works for both. I know it's a solution. So then let's just do one more together, and then I'll actually have you do a couple on your own. So again, I'm going to follow my steps that I outlined above. So I'm going to draw my line, just like I'm adding like 2 big numbers. I'm going to draw a circle, and I'm going to look and see what would get my variables to eliminate. So if I were to add these, 3 and negative 3 add to 0, and so I know that my chance for elimination is going to be addition, so plus. And so now I'm going to do my tap, tap, tap method. So 3x plus negative 3x is 0. I don't even need to write it. 4y plus 5y, that's 9y. Bring down my equal sign. 8 plus 10 is 18. And so now I've got y being bothered by 9. It's multiplying, therefore I'm going to divide. 18 divided by 9 is 2. I have half of the ordered pair that I need. Don't forget that I need the x part. And so now I'm going to take my top equation, no other reason other than it's the top one, and it just doesn't have a negative, but it won't matter. And instead of 4 times y, well, now I know that y is 2. And so then I've got 3x plus 8 equals 8. I'm going to subtract 8 from both sides. I've got 3x equals 0. Divide both sides by 3. 0 divided by anything, it doesn't matter, is 0. And so my point of intersection is 0, 2. All right, so what you're going to do is you're going to pause the video. You're going to try examples 3 through 5, and you're going to press play when you are ready to check your answers. Okay, so on example 3, I just want to point out that really this is a negative 4, and so that's why addition is going to be what cancels these out, because negative 4 plus 4 is 0. And that's actually the case, just really quick, on all of these remaining examples. So just something to keep in mind. That negative, and that negative are attached to those variables. So I'm going to add. So I've got 8x plus 3x is 11x. Negative 4 plus 4 cancels out or eliminates itself. And then negative 4 plus 15 is 11. And so then x would equal 1. And so then I've put that into the top equation. 8 times 1 is 8, which I subtract to get rid of that on both sides. Don't overlook this negative. Remember that kind of has to stay attached, and so when I go to divide, I'm dividing by -4, and so y would equal 3. And so my point of intersection is 1, 3. And I could just check that really quick. So 8 times 1 is 8, 4 times 3 is 12, 8 minus 12 is -4, and then 3 times 1 is 3, 4 times 3 is 12, 3 plus 12 is 15. And so that checks out on that example. On example 4, again, I have to add because it's -3 plus 3, so that's what is going to cause it to disappear. 9x plus 7x is 16x. 18 plus 30 is 48. Divide both sides by 16. I'm going to get x equals 3. And so then I happen to plug it in here. So 9 times 3 is 27 minus 3y is 18. We're going to subtract 27 from both sides because 27 minus 27 is 0. Don't forget that that negative has to stay attached with 3. And then divide both sides by -3, and I get y equals 3. And so x is 3, y is 3, 3, 3. And I can check that again. 9 times 3 is 27, 3 times 3 is 9, 27 minus 9 is 18, 7 times 3 is 21, 3 times 3 is 9, 21 plus 9 is 30. So it checks out. And then on my last example, example 5, again, I'm going to add because it's -2y plus 2y, 3x plus 5x is 8x, 10 plus 6 is 16. Divide both sides by 8, I get x equals 2. I put that in here. 3 times 2 is 6. And then we're going to subtract 6 from both sides. And again, that negative is going to come down. -2y equals 4. Divide both sides by -2. And y equals -2. And if I check it, 5 times 2 is 10. 2 times -2 is -4. 10 plus -4 is 6. This one's a little trickier. 3 times 2 is 6, but then it's a -2 and a -2, which is y. So that's going to become a plus. And so 6 plus 4 is 10. And so again, it checks out. Okay, so on our previous examples, we were using addition to eliminate a variable. And now we're going to use subtraction. And so you can see here that if I were to do 3y minus 3y, that would cause my y variable to eliminate. And so that's what I'm going to do. So I'm going to draw my line, I'm going to put my circle, and then this time inside the circle, I'm going to put subtraction. And I still want to focus on that tap, tap, tap method because I want to make sure that I'm really subtracting correctly, especially when it's subtracting. It's pretty important. So I've got 4x minus 5x, and that's going to be -1x. And then I already know, but I'll do it again, that 3y minus 3y is going to be 0y, so I don't have to write it. My equal sign comes straight down. And now this one, I really want to say this one out loud. 2 minus -2. And remember, you can definitely use a calculator. You can also write it out. So 2 minus -2. And in order to do that, we do keep, change, opposite, and so then that's going to become 4. And then to get x by itself, I'm going to divide both sides by -1, and so x equals -4. And so now I'm going to take that, and I'm going to plug that into maybe the top equation. So 4 times -4 plus 3y equals 2. That's going to be -16 plus 3y equals 2. I'm going to add 16 to both sides. So I get 3y equals 18, and if I divide by 3, I'm going to get y equals 6. And remember, I always write my answer in xy format, and so I've got -4, 6. And again, I could always go back and check my answer by doing 4 times -4 is -16, 3 times 6 is 18, -16 plus 18 is 2, 5 times -4 is -20, 3 times 6 is 18, -20 plus 18 is -2. So I know that my answer is correct because it works in both equations when I plug it in. So you're going to pause the video, and I'd like you to try examples 7 and 8, and you're going to be using subtraction to eliminate a variable. Really focus on making sure that when you subtract each individual component, that you're coming up with the right number. Feel free to use a calculator. Press play when you're ready to check your answers. All right, so on example 7, again, we knew we were going to subtract because 6y minus 6y is 0. So I'm going to do 5x minus 7x is -2x, and 4 minus 8 is -4. Divide both sides by -2. Remember that a negative divided by a negative is positive. And so then I've got x equals 2, and so I plugged that into the top equation. So 5 times 2 is 10. Then I subtract 10 from both sides. 4 minus 10 is -6. And then divide both sides by 6 to get y equals -1. So my point of intersection, my solution is 2, -1. And then on example 8, 2x minus 2x is going to eliminate. 5y minus 3y is going to be 2y. 10 minus 6 is going to be 4. Divide both sides by 2, I get y equals 2. I plugged that into the top equation, so 2x plus 5 times 2 is 10. 5 times 2 equals 10, so I'm going to subtract 10 from both sides, and so then I brought that over here. So my new equation says 2x equals 0. Divide both sides by 2. Remember, 0 divided by anything is 0.
and so x equals 0, and my point of intersection is 0, comma 2. One thing that might be just worth pointing out is that some people like to take a system and they'd rather not subtract. I think most people would prefer to add when it's possible. And so say example 6, where it was 4x plus 3y equals 2. What you could do is you could take that bottom equation and just multiply everything. So the bottom equation was 5x plus 3y equals negative 2. You could multiply everything by negative 1, and what that will do is it will change everything to its opposite. So 5x would become negative, 3y would become negative, 2 would become positive. And now when you go to eliminate, you could actually add instead of subtract. So just know that that's an option that's out there for you, but don't feel like that's something that you have to do. I hope you enjoyed this set of notes. Thanks.